Mohon perhatian kepada Bapak dan Ibu, acara akan segera kami mulai. Untuk itu kami mohon perkenan Bapak dan Ibu untuk dapat mengaktifkan video dan menonaktifkan audio selama acara berlangsung. Terima kasih. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan. Yang terhormat Deputi Bidang Konservasi Arsip, Bapak Dr. Kandar MAP. Yang kami hormati, para narasumber, Mr. James Bird, President and CEO of Preservation Technologies LP, and Mr. John Betty PhD, Technology Manager at Preservation Technologies LP. Yang kami hormati pula, para Bapak dan Ibu hadirin yang berbahagia. Puji dan syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala, Tuhan yang Maha Esa, karena atas berkat dan rahmat-Nya pada hari ini, Rabu tanggal 2 Maret 2022, kita semua diberikan kesehatan dan diperkenankan untuk dapat bergabung, baik melalui aplikasi Zoom Cloud Meeting maupun melalui channel YouTube Arsip Nasional Republik Indonesia dalam acara webinar Preservasi dengan tema De-Acidifikasi Arsip untuk Mengurangi Keasaman Arsip Kertas yang diselenggarakan oleh Direktorat Preservasi Arsip Nasional Republik Indonesia. Bapak dan Ibu yang berbahagia, sebelum acara dimulai, kami informasikan bagi Bapak dan Ibu yang mengikuti webinar melalui Zoom Meeting bahwa dalam acara hari ini terdapat penerjemahan bahasa Indonesia ke dalam bahasa Inggris pada channel Inggris dan penerjemahan bahasa Inggris ke dalam bahasa Indonesia pada channel Indonesia. Sehingga kami persilakan kepada Bapak dan Ibu untuk dapat mengaturnya masing-masing sesuai dengan kebutuhan. Mengawali acara pada pagi hari ini, marilah bersama-sama kita menyanyikan lagu kebangsaan Indonesia Raya, dilanjutkan dengan Mars Kearsipan Indonesia. Hadirin dimohon untuk duduk dengan sikap sempurna.
Emban tugas penyelenggaraan kearsipan, terkenal kembangkan diri, terus berinovasi, melestarikan memori masa, wujudkan membangkitkan negeri. Kami menjamin tersedianya arsip sebagai bukti sebagai jati diri bangsa kita. Selalu responsif, antisipatif, bersikap profesional, sinergikan semangat perubahan, satukan langkah dalam menjaya. Kami menjamin tersedianya arsip sebagai bukti akuntabilitas kinerja, mampu menghadapi segala tantangan, bangga jadi bangsa Indonesia. Melangkah kearsipan Republik Indonesia, junjung tinggi identitas bangsa, jaga warisan nasional dan budaya demi kejayaan Indonesia. Kearsipan Republik Indonesia.
Bapak dan Ibu yang berbahagia, tentunya kita berharap agar acara pada hari ini dapat berjalan dengan tertib, lancar, dan mendapatkan keberkahan dari Tuhan Yang Maha Esa. Untuk itu, marilah kita tundukkan kepala kita sejenak untuk berdoa bersama yang akan dipandu oleh Bapak Dwi Ariwibowo. Kepada Bapak Dwi Ariwibowo, kami persilakan.
Terima kasih, MC. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Mohon izin, saya akan memandu doa secara Islam. Kepada Bapak dan Ibu yang hadir, dimohon berkenan menyesuaikan menurut agama dan kepercayaan masing-masing. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Innal hamdulillah wa nahmaduhu wa nasta'inu wa nastaghfiruhu wa na'udzubillahi min syururi anfusina wa min sayyiati a'malina. Man yahdihillahu fala mudhillalah wa min yudhlilhu fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma sholli ala sayyidina Muhammadin wa ala alihi wa ashabihi ajmain. Amma ba'du. Ya Allah, ya Tuhan kami, tiada kata dan rasa yang pantas kami haturkan kepada Engkau selain syukur kami padamu atas nikmat dan karunia yang telah Engkau anugerahkan kepada kami, sehingga kami pada hari ini dapat hadir dalam keadaan sehat dan sempat untuk mengikuti workshop online Preservasi Arsip dengan tema De-Acidifikasi Arsip untuk Mengurangi Keasaman Arsip Kertas. Maka dengan itu ya Allah, kami memohon ridho dan izin-Mu. Berkahilah semua langkah dan perbuatan kami, dan jadikanlah ini semua sebagai nilai ibadah dalam ikhtiar kami menjalankan tugas dan tanggung jawab kami. Ya Allah yang Maha Mengetahui, ilmu-Mu begitu luas dan tak terbatas. Oleh karena itu, anugerahkanlah kepada kami ilmu yang bermanfaat sebagai bekal kami dalam menjalani hidup dan kehidupan, serta berikanlah kami kekuatan untuk mampu mengamalkan ilmu yang telah Engkau anugerahkan kepada kami. Limpahkanlah kepada kami yang hadir pada acara kali ini kesehatan, kekuatan, kemudahan, dan keikhlasan, serta kearifan untuk mengikuti webinar yang kami selenggarakan ini. Ya Allah yang Maha Pengasih dan Maha Penyayang, jagalah raga dan jiwa kami selalu dalam keadaan sehat dan semangat. Jauhkanlah kami dari rasa malas dalam menuntut ilmu, agar kami dapat terhindar dari rasa pahitnya kebodohan. Ya Allah sebaik-baik pelindung, kami berlindung kepadamu dari rasa sedih dan duka. Kami berlindung kepadamu dari rasa letih dan lemah. Dan kami berlindung kepadamu dari kesalahan yang terlanjur kami lakukan. Ya Allah yang Maha Perkasa, tahun ini kami masih Engkau uji. Pandemi belum juga meninggalkan negeri kami. Atas kuasa-Mu ya Allah, berikanlah kami kekuatan untuk dapat menghadapinya, dan jauhkanlah negeri kami darinya, agar tercipta rasa aman bagi kami dalam menjalani kehidupan kami. Ya Allah yang Maha Pemurah, Engkau yang Maha Pengampun atas segala dosa, ampunilah dosa kami, dosa kedua orang tua kami, dosa para pemimpin kami, dosa para pahlawan serta pendahulu kami. Tempatkanlah kami di dalam rindungan dan rahmat-Mu serta ampunan-Mu. Ya Allah yang Maha Mulia, kabulkanlah permohonan dan doa kami, serta masukkanlah kami ke dalam golongan orang-orang yang pandai bersyukur. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina min ladunka rahmatan wa hayyi' lana min amrina rasyada. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhanaka rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin. Walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Hadirin yang kami hormati, sebagai pembukaan acara pada hari ini, maka akan disampaikan sambutan pembukaan oleh Deputi Bidang Konservasi Arsip. Yang terhormat Bapak Dr. Kandar, MAP, kami persilakan.
Terima kasih Mbak Berli selaku pembawa acara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam damai sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Yang terhormat Mr. James Boots selaku Presiden dan CEO Preservation Technology LP, pengembang teknologi untuk Deasidifikasi dalam pelestarian buku dan dokumen. Yang terhormat Profesor John Betty selaku Technology Manager di Preservation Technology LP sebagai pakar kearsipan dalam bidang konservasi kertas di Amerika. Atas nama pimpinan Arsip Nasional Republik Indonesia, saya menyampaikan terima kasih kepada Mr. James Booth dan Mr. John Betty yang telah bersedia sharing knowledge pada webinar kali ini. Para pejabat struktural dan fungsional di lingkungan Arsip Nasional Republik Indonesia, para peserta webinar yang ada di ruang Zoom dan di kanal YouTube Arsip Nasional Republik Indonesia, wabil khusus saudara moderator dan penerjemah dan seluruh panitia penyelenggara webinar seri pertama Direktorat Preservasi Arsip Nasional Republik Indonesia yang kami banggakan. Hadirin sekalian yang saya hormati, pertama-tama marilah kita memanjatkan puji dan syukur kehadirat Allah SWT, Tuhan yang Maha Kuasa, karena atas perkenannya kita dapat bersama-sama menghadiri acara webinar secara online dengan menggunakan aplikasi Zoom Meeting dalam rangka webinar Preservasi Arsip Seri ke-1 tahun 2022 dengan tema Deasidifikasi Arsip untuk Mengurangi Keasaman Arsip Kertas. Selanjutnya kami ucapkan terima kasih juga untuk para panitia yang berusaha payah mengorganisir acara webinar pertama ini tahun 2022 sehingga dapat terlaksana dengan baik. Dengan banyaknya tantangan, sebagian panitia harus berada di rumah masing-masing karena terpapar COVID, pandemi COVID masih berlangsung dan kita tetap harus menerapkan protokol kesehatan hidup sehat. Hal ini demi melindungi diri dan menjaga kesehatan kita bersama dari ancaman pandemi. Semoga narasumber kita, Mr. James Booth dan Mr. John Betty juga dalam keadaan sehat walafiat. Bapak Ibu yang kami hormati, webinar Preservasi Seri ke-1 tahun ini menghadirkan narasumber dari Amerika, 2 orang pakar kearsipan yang telah banyak menjadi narasumber di berbagai event, serta keduanya bekerja di Preservation Technology LP, PTLP, sebuah perusahaan di Amerika yang berperan untuk membantu lembaga dan organisasi yang membutuhkan pelestarian terhadap koleksi mereka. Selain itu, telah banyak berperan dalam menangani arsip dan dokumen kertas dan menyelenggarakan event yang bermanfaat besar bagi dunia kearsipan, khususnya konservasi kertas dengan cara deasidifikasi. Narasumber kali ini adalah Mr. James Booth yang membawakan topik Deasidification, the Process and Application, dan Mr. John Betty yang membawakan topik The Chemistry and Science of Paper Preservation. Sebagai salah satu upaya Arsip Nasional Republik Indonesia untuk menyikapi upaya pelestarian arsip, utamanya dalam mengurangi kerusakan arsip karena tingkat keasaman pada arsip kertas yang tinggi di daerah tropis ini dengan melakukan deasidifikasi. Kertas merupakan salah satu media yang sering dan umum digunakan dalam penciptaan arsip. Kertas itu sendiri memiliki pH, potensial hidrogen, merupakan hal yang paling sering diperhatikan dalam melakukan preservasi arsip bermedia kertas. Kualitas arsip bermedia kertas yang baik atau netral mempunyai pH 7. Di bawah 7 artinya bersifat asam, sedangkan di atas 7 berarti basa atau alkali. Untuk menghindari rusak dan rapuhnya suatu arsip, terutama yang menggunakan media kertas, perlu dilakukan preservasi arsip untuk memperbaiki dan memperkuat fisik arsip yang mengalami kerusakan atau mengalami penurunan kualitas secara fisik. Salah satu kegiatan preservasi arsip dengan media kertas yaitu deasidifikasi arsip. Deasidifikasi arsip itu sendiri merupakan cara untuk menetralkan asam pada kertas yang sedang merusak kertas dan memberikan bahan penahan untuk melindungi kertas dari pengaruh asam yang berasal dari luar. Untuk selanjutnya, kami mohon para narasumber untuk dapat sharing knowledge kepada kami di Indonesia, khususnya terkait dengan deasidifikasi arsip kertas, agar mampu meningkatkan kemampuan pengetahuan kearsipan khususnya para arsiparis di era teknologi dan di era pandemi ini. Alhamdulillah hingga kemarin siang sudah terdaftar peserta yang ikut acara webinar Seri pertama ini ada 2.290 peserta. Banyaknya jumlah peserta yang mengikuti webinar ini diharapkan menjadi bukti kesadaran para anak bangsa untuk menyikapi perkembangan kearsipan yang sedang kita hadapi. Saya selaku pimpinan Lembaga Kearsipan Nasional Republik Indonesia berharap kepada seluruh pimpinan lembaga kearsipan daerah, perguruan tinggi, pencipta arsip, dan arsiparis untuk tetap melestarikan arsip statis yang bermedia konvensional, khususnya kertas, sesuai dengan amanat Undang-Undang Nomor 8 Tahun 1997 dan Undang-Undang Nomor 43 Tahun 2009. Walaupun arsip sudah didigitasi atau dialih media, arsip asli harus tetap dilestarikan. Di tengah-tengah kita saat ini telah memasuki era digital dalam mengelola informasi. Hadirin yang berbahagia, kita manfaatkan dua pakar kearsipan dari Amerika Serikat ini. Tentu kita sangat sulit untuk menghadirkan beliau pada acara webinar di Indonesia seperti yang telah dilakukan oleh Arsip Nasional pada kesempatan hari ini. Kita manfaatkan untuk berdiskusi dengan para narasumber tersebut, tentu akan fokus pada kegiatan deasidifikasi arsip kertas. Sekian pengantar saya ucapkan selamat mengikuti webinar kepada seluruh peserta, semoga bermanfaat bagi lembaga dan negara yang kita cintai, menuju SDM unggul Indonesia maju. Selamat memori kolektif bangsa, selamat bukti sejarah peradaban bangsa Indonesia. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bapak Kandar atas sambutan pembukaan yang telah disampaikan. Dengan demikian, acara pembukaan webinar preservasi dengan tema Deasidifikasi Arsip untuk mengurangi keasaman arsip kertas secara resmi telah kita ikuti bersama. Dan selanjutnya kita akan masuk pada sesi pemaparan materi oleh para narasumber yang akan dipandu oleh Arsiparis Muda Andri sebagai moderator. Kepada Bapak Ahmad Dedi Fauzi Eshum, kami persilahkan Bapak untuk dapat mengambil alih acara.
Ya, terima kasih kepada Ibu Berli selaku MC atas pembukaannya. Suara saya terdengar? Jelas? Oke.
Jelas, Bapak.
Ya, sebelumnya saya ingin menyapa para undangan khusus dan narasumber dalam acara ini terlebih dahulu. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam damai sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, Salam, Salam Kebajikan. Yang kami hormati Deputi Konservasi Arsip Nasional Republik Indonesia, Bapak Kandar. Yang kami hormati Direktur Preservasi Arsip Nasional Republik Indonesia, Bapak Agus Santoso. The Honorable Mr. James Bird, President and CEO of Preservation Technology, the first speaker for today's webinar. The Honorable Mr. John Betty, PhD, Technology Manager at Preservation Technologies, the second speaker for today's webinar. Yang kami hormati Koordinator Restorasi Arsip, Bapak Suwarto. Yang kami hormati Koordinator Penyimpanan Arsip, Bapak Dani Sugiharto. Yang kami hormati Koordinator Reproduksi Arsip, Bapak Edi Saprono. Yang kami hormati Koordinator Laboratorium Arsip, Ibu Yana Suryana. Serta saya ucapkan terima kasih kepada Bapak Ibu, para undangan, dan para peserta seminar yang berbahagia atas keikutsertaannya dalam webinar preservasi kali ini yang saya sayangi. Selamat pagi, sahabat arsip dimanapun Anda berada. Apa kabar semuanya? Sehat ya? Semoga seluruh peserta dalam acara ini selalu dilimpahkan kesehatan selalu. Amin, amin ya robbal alamin. Tiada kata yang paling pantas pada kesempatan kali ini yang kita patut haturkan, yaitu puja dan puji syukur kehadirat Allah Subhanahu wa Ta'ala, Tuhan yang Maha Pemurah. Dengan rahmat dan karunia-Nya, kita dapat mengikuti acara webinar online dengan tema Deasidifikasi Arsip untuk Mengurangi Keasaman Arsip Kertas. Sebelum kita memulai webinar pada pagi hari ini, izinkan saya memperkenalkan diri. Saya terlebih dahulu, nama saya Ahmad Deddy Fauji. Saya adalah seorang arsiparis muda di Arsip Nasional Republik Indonesia. Pada kesempatan kali ini, saya akan menjadi moderator yang memandu jalannya webinar dan diskusi kita pada pagi hari ini. To Mr. Bird and Mr. Betty, hello, good morning in Jakarta and good evening in United States of America. It is a honor to have you as the speaker today. Before we start, I would like to give some announcement for all the participants today. And since all the participants today are Indonesians, I would like to use Indonesian language for the announcement. There is an interpreter at the interpreter channel if you wish to listen it in English at the English channel. Dapat saya informasikan bahwa webinar kali ini merupakan webinar Preservasi seri pertama di dalam rangkaian serial webinar Preservasi di tahun 2022 yang dilaksanakan oleh Direktorat Preservasi Arsip Nasional Republik Indonesia. Webinar ini direkam dan rekamannya dapat diakses setelah acara ini selesai di YouTube channel kami, Arsip Nasional RI. Jadi Bapak Ibu sekalian silakan like dan subscribe channel YouTube ANRI agar dapat mengetahui info event-event kami yang akan datang. Baiklah, sebelum para narasumber menyampaikan materinya, saya akan terlebih dahulu membacakan peraturan dalam webinar kali ini. Antara lain, yang pertama, para narasumber kami beri waktu untuk penyampaian materi masing-masing selama 45 menit. Kedua, selama para narasumber menyampaikan materi, tidak ada interupsi dari para peserta. Ketiga, setelah narasumber selesai menyampaikan paparannya, maka akan dilanjutkan dengan sesi tanya-jawab atau diskusi. Dalam sesi diskusi, pertanyaan Bapak Ibu akan kami bacakan dan kemudian akan dibahas oleh pembicara. Oleh karena itu, silakan Bapak Ibu menyampaikan pertanyaan melalui fitur chat pada aplikasi Zoom dan YouTube. Tim panitia kami akan membuka fitur chat beberapa saat sebelum para pembicara menyelesaikan paparannya dan memilih pertanyaan paling bagus dan menarik untuk diajukan kepada pembicara dan akan diberikan souvenir menarik untuk 3 penanya terbaik dari Mas Andri. Serta jangan lupa menyebutkan nama serta instansi Bapak Ibu sebagai penanya. Saudara-saudara sahabat arsip yang kami hormati, sebagaimana tercantum pada pengumuman atau flyer webinar pada kesempatan hari ini akan membahas tentang deasidifikasi arsip untuk mengurangi keasaman arsip kertas secara teknis. Arsip merupakan memori kolektif bangsa yang perlu dilestarikan baik terhadap fisik maupun isi informasi yang terkandung di dalamnya. Salah satu media yang dapat digunakan untuk penciptaan arsip adalah kertas. Kertas merupakan media yang paling umum dan paling sering digunakan sebagai media arsip. Arsip Nasional Republik Indonesia sebagai lembaga kearsipan yang memiliki keasaman arsip kertas juga melakukan kegiatan konservasi. Salah satunya adalah preservasi. Salah satu kegiatan preservasi yang biasa dilakukan di unit restorasi arsip adalah dengan melakukan deasidifikasi arsip. Deasidifikasi arsip adalah cara untuk menetralkan asam pada kertas yang sedang merusak kertas dan memberi bahan penahan atau buffer untuk melindungi kertas dari pengaruh asam yang berasal dari luar. Akan tetapi, dalam perjalanannya, proses deasidifikasi ini sedikit atau jarang diketahui dan dilaksanakan oleh masyarakat pada umumnya. Seringkali arsip kertas langsung masuk ke tahap laminasi, serta tidak melakukan pengukuran kandungan asam pada arsip yang hendak dideasidifikasi dan tidak pula sesudahnya. Padahal, proses deasidifikasi arsip dilakukan untuk menghilangkan kandungan asam yang ada di dalam arsip kertas. Oleh karena itu, ketika kita berurusan dengan proses deasidifikasi arsip untuk mengurangi keasaman pada arsip kertas, beberapa poin harus dijawab. Pertama adalah mengapa proses deasidifikasi arsip pada arsip kertas itu penting, bagaimana cara mengidentifikasi arsip kertas agar siap untuk dilakukan deasidifikasi, peralatan dan perlengkapan apa saja yang diperlukan dalam melakukan deasidifikasi pada arsip kertas, adakah inovasi yang terjadi pada proses deasidifikasi pada arsip kertas yang memiliki tingkat keasaman yang berbeda. Lalu terakhir adalah siapa yang harus terlibat dan apakah ada kualifikasi khusus untuk menjadi tim atau praktisi dalam melakukan deasidifikasi. Bagaimana memulai dan mempertahankan proses tersebut. Baik, saya kira beberapa pertanyaan dan kemudahan kita mengenai proses deasidifikasi pada arsip kertas dapat terjawab dengan mendengarkan paparan dari para narasumber kita pada pagi hari ini. Untuk itu, dalam seminar ini akan hadir dua narasumber yang luar biasa yang didatangkan langsung dari negara Amerika Serikat. Dan sebagai informasi bahwa waktu pelaksanaan berbeda jika di Indonesia memiliki waktu hari Rabu pagi, di Amerika Serikat memiliki waktu hari Selasa malam yang akan menyampaikan gagasannya mengenai deasidifikasi arsip. Good evening, Mr. Bird. How are you today? Good evening, Mr. Bird. How are you today?
Yes. Good morning.
How are you today?
I'm fine, thank you. How are you?
I'm fine too. I'm wonderful today. It is a pleasure to have you sharing your knowledge today. Before starting the presentation, I would like to describe shortly about your CV to all the audience today. Kepada panitia untuk men-share screen CV. Mr. James Bird is the President and CEO of Preservation Technology LP US-based company that is world leader in collection preservation. Diawali pada tahun 1992, Mr. James Bird memimpin tim desain yang mengembangkan teknologi deasidifikasi massal Bookkeeper untuk menyediakan metode yang aman dan efektif untuk menetralkan efek berbahaya dari asam untuk buku dan dokumen tanpa menggunakan air. Pengembangan proses berfokus pada pencapaian standar kualitas tinggi yang ditetapkan oleh Perpustakaan Kongres Amerika Serikat, dan teknologi Bookkeeper masih merupakan satu-satunya proses yang memenuhi standar tersebut. Selama 20 tahun terakhir, Mr. James Bird telah memimpin perusahaan melalui ekspansi besar penjualan peralatan dan layanan pelestarian ke pasar internasional. Peralatan deasidifikasi massal Bookkeeper yang dirancang khusus sekarang beroperasi di 10 lokasi, termasuk Perpustakaan Nasional, Arsip Nasional, dan Universitas Besar, dan produk semprotan spraying De-Acidification Bookkeeper digunakan oleh konservator di seluruh dunia. Sebagai pengakuan, Departemen Perdagangan Amerika Serikat menganugerahkan penghargaan I kepada perusahaan tersebut untuk keunggulan dalam layanan ekspor. Wah, luar biasa ya. Mr. James Bird adalah seorang insinyur profesional terdaftar dengan gelar di bidang teknik kimia. Sebelum Preservation Technologies, beliau bekerja di industri kimia sebagai manajer teknik perusahaan dan kemudian sebagai mitra pendiri dan wakil presiden dari sebuah perusahaan konsultan teknik. Dia memegang 7 paten yang berkaitan dengan bahan kimia dan proses pengawetan dan bertugas di komite ICO yang mengembangkan spesifikasi teknis ICO untuk deacidification. Saat ini beliau bertugas dalam Dewan Ekspor Distrik Departemen Perdagangan Amerika Serikat dan memberikan panduan kepada seluruh perusahaan yang baru melakukan ekspor dalam bidang deacidification. So that's all a brief profile of Mr. Bird. To Mr. Bird, without further ado, the floor is yours.
Thank you very much for that introduction. It's a pleasure to be here, and I hope, can you hear me okay?
Yes, okay. Your voice
Share
can, yeah.
Share my screen.
Yeah, very much. Okay, Mr. Bird, you can begin for your presentation.
Okay, is my screen okay?
Yeah.
Okay.
Okay.
First of all, thank you very much for that kind introduction. And we're very pleased to be participating today. John Beatty and I have been involved in deacidification for a good bit of our career. And it's wonderful to see an institution like the Archives taking an interest in preservation through deacidification. It's something sorely needed to protect our cultural heritage. So today we're going to try to answer a lot of the questions that you asked about how this process should work. And I hope by the end of our presentation, you have a sense of what we're capable of doing and what the world is doing right now, what other institutions are doing in terms of trying to preserve their documents and archives and cultural heritage. Did the screen advance properly? Okay, so as we said, I'm President and CEO of Preservation Technologies. The company was formed 30 years ago, and we've been working with the Library of Congress through that first 10 years to develop the process that would meet their standards, and ever since, for that matter. The company has been expanding for the last 20 years. We've been working internationally as well. began our first international efforts were in the Netherlands, and we've expanded them throughout Europe. We now have operations in Asia, in Japan, and Korea, and in Africa, and Middle East. So this is a worldwide problem, and we're a small company, but in a location or in a market that sorely needs.
Excuse me, Mr. Bird.
Yes.
Your presentation is not.
It's frozen.
Yeah, it's your presentation is not your PPT. It's not looking at the Zoom meeting.
Okay.
You can click off your PPT.
Yep.
Yeah. Okay. Are you handling for your PPT today?
Yes. Hold on.
Okay. Yes. Okay. Yeah. You can share your PPT, Mr. Bird, or
Yes. Okay.
okay. You can help from the committee to using your PPT.
Let me close. Sorry.
Oh yeah. Baik.
Okay. Are you seeing my screen now?
Oh yeah. No, not yet.
No. Okay. Right.
You can click for your share screen. Okay. Yes,
Okay.
it is okay. Yeah. Thank you, Mr. The floor is yours, Mr.
Okay. Okay. So we're talking about development as a company and expanding our efforts internationally. And you mentioned as part of our introduction that we were a winner of the President's E Award for Excellence in Export Service in 2017. And then in 2020, we were achieved certified or ISO 9001 for quality purposes. So we're very pleased with the advancement of the company and our ability to grow both in the United States and internationally. We learn a lot from working in international markets because it's such a broad field. And so it's wonderful that we're able to work with your archives. We do a lot of things with preservation technologies. We're interested in all forms of preservation of cultural heritage. We have a division that works in digitizing audio, video, and film in other areas. But today, we want to talk about deacidification. And this is the field that we've been working in for 30 years now. When we talk about deacidification, there's several things that we want to talk about. And the first is, what are the problems associated with acid in paper? And then we want to talk about what processes are available to deal with those problems. And finally, once we figured that out, what kind of programs can we set up to deal with these issues in our institutions? So we'll start with detailing the problems that we find with acid in paper. First of all, we'll answer the question quickly, why is there acid in paper in the first place? The beaker you see in this slide has chopped up bits of paper in water with a dye added to it, and that dye is a pH sensitive color. So the yellow is telling you that this paper was very acidic before we started. This is what we find in a lot of paper throughout the archives and books and documents in libraries and archives. So why is the acid? Well, first of all, the paper making process itself can leave acid in the paper. Processes where they bleach the paper to make it whiter, when they make additives for sizing or additives for dyes and adhesives, can leave acid in the paper to begin with. Up until about 1980 and 1990, most paper was made in this way. Beginning in the 1980s, we began to change the paper making process so that we did not leave acid in the paper. But up until then, the predominant processes left acid in the paper. So first of all, it can come right from the process where we make it. And second, what we put on the paper is also a contributing factor. So this is an example of paper that has iron gall ink. Iron gall ink is a very acidic material that if you write on paper can actually burn through the paper itself. So that's the second source of how you can get material onto paper. The third is air pollution itself. Air pollution has had a significant impact on our shared collections. In the United States, there have been studies done with books that were taken from the West Coast libraries and our East Coast libraries. Because on the West Coast, the relative amount of pollution is much less than on the East Coast, just because of the proximity of factories and industry. And we find that if you take a book from the East Coast and a book from the West Coast that are identical in all aspects and bring them together, the one on the West Coast will be in relatively good condition. The one on the East Coast might be in very poor condition. It's all because of the environment in which they were stored, and air pollution is a significant contributor. In the Netherlands, the National Library and the National Archives are both located in the downtown area of The Hague. The Hague, historically, that's been a very polluted area that they were in. So they actually installed very specialized HVAC systems to control the amount of pollutants that could get into their institutions. And they actually maintain a positive pressure on their institutions at all times so that air will push out, but outside air will not push in. Pollution is a significant potential contributor to acidity in paper. Finally, the other issue is that acids will migrate in storage. Acids themselves in paper can be volatile. And so if you take a piece of paper that's acidic and put it next to a piece of paper that's alkaline, the alkaline paper will become acidic because the acids move to the alkaline area. If you buy a storage box, like we see in this picture, and the storage box may be alkaline to begin with, but you fill it with acidic paper, in a year or two, you'll find that box has become acidic. So what we find, in summary, what we're finding is that acid comes to paper in many ways. It can be left there by the paper making process. It can be added by the way you handle it with inks and dyes. It can come from the pollution. It can come from other materials in the library. It's a significant problem that is endemic in our storage facilities. So why is it a problem in the first place if there's acid in the paper? First of all, and I'm going to let John Beatty go into the details of a lot of the chemistry, but in the short version, the reason paper is strong in the first place is the cellulose fibers. Cellulose is a long chain polymer, lots of links in the chain. It's very strong. If you try to stretch it tensile-wise, it's very strong. If you try to bend it over, it's very flexible. So it's a wonderful material for something like a piece of paper. But it is bound together, the links are bound together by a single molecule of oxygen. And when we have acid available, what happens is a process called acid hydrolysis. Acid comes in and breaks the chain. And when you break the chain, then you begin to make the paper weaker. So if we start off with a normal piece of paper or a new piece of paper, we might find that it has 800 or 1,000 more links in the chain. But if I break one, then on average, that chain has been cut in half. So now instead of 1,000, maybe I've got 500 links in my chain. And if I break a couple more, then on average, I might have only 200 or 300 links in my chain. If I go from 1,000 down to 200 links, and it doesn't take very much to do that, then I'm going from something that is fairly strong to something that is fairly brittle. The issue is that if I break less than 1% of those bonds, I can go from a strong piece of paper to a brittle piece of paper. It's why paper that is acidic can degrade very quickly. And the more acidic, the faster that happens. So we have to make sure we deal with acids before they have a chance to do this to paper. Okay, so how large is the problem of acid in paper? We've all seen the storage depots. We all know what the archives look like, the many floors of materials. How big is the problem? Well, more than 90% of books and documents that are from the 1850s to the 1980s are acidic. It's a staggering amount of material worldwide. The Library of Congress identified that they felt they needed to treat 7.5 million books, 20 million documents, and 100,000 comic books It was their first estimate of how much material that they needed to treat on a relatively urgent basis. This is material that in many cases is digitized or will be digitized, but is still of such value that they do not want to lose the original. When we talk about the Library of Congress expectations, they believe that deacidification will extend the life of paper by 3 to 5 times. 3 to 5 times. It means that if the paper has a life of 100 years or 50 years before you deacidify it, then it should last anywhere from 300 to 500 years or more by deacidification. It's a big boost in terms of how much time you buy for your books. The other piece of that is that if you don't deacidify, if you wait 10 years to do that or 20 years to do that, because you've lost 3 to 5 times the life, you've actually lost maybe 60 to 100 years of useful life off your books or off your documents. It's a process that's urgent and needs to be dealt with on an urgent basis because you're losing your collections otherwise. Who else has made estimates like this? The National Archives in the Netherlands thinks they have as many as 100 million documents that they need to treat or more as a first estimate. The National Library of Canada has over 1 million books. The National Library of Poland, over 1 million books. And even institutions, smaller institutions, such as the Jagiellonian University, identified 500,000 books that they needed to treat just in their facility. In all cases, they're also doing newspapers and documents and a wide range of materials. In Poland, the National Library of Poland put together some interesting information about their collection. This graph shows the data points are on the bottom run for the century of 1900 to 2000. And on the scale on the left is pH. pH is a measure of how acidic documents are, how acidic material is. 7 is considered neutral. And if you're less than 7, it's acidic. And the lower the number, the worse it is. If you're above 7, then it's alkaline. And generally above that number is, anywhere above that number is okay for the paper that we're talking about. If you look at this, and we look at the range from about 3 to 6.5, all of that is acidic, and it continues from 1900 all the way through 1995. A substantial amount of material, and it's quite low. When we're talking about pH in the range of 3 to 4, that is very quickly destroying the structure of the books and the documents. It's necessary to move quickly if you want to retain the strength of this material. What we see up in the top is in that period beginning about 1995, in their case, a lot of the material that they're collecting now is alkaline. It's in the range of 7 to 8. That's perfect. You know, the paper will last a long time if it's got a pH of about 7 and 8. So that's our goal. We want to take all of these materials down here that are on 3 and 4 and 5 and move it up into that 7 and 8 range if we can. That's the ideal goal of what we're doing. The university also put together graphs showing the percentage of the materials they've got. So not only do they demonstrate how low they are, but you can see from these graphs, the orange bars are telling you that 100% of material is not from this older material. And it's not until you get up again into the 1990s, and then about 1995 and 96, that you see a significant drop in the kind of material. Even going back, when you look at times from 1810 to 1850, the books that they had then, they didn't have as many, but they're all acidic. So if you want to keep your cultural heritage, you know, we know that you have to look at dealing with the acidity of books. So it's significant, it's worldwide. It's a big problem for all of our institutions, archives, libraries, universities, government agencies. And so what do we do? So now we'd like to take a look at the processes that are available to deal with this problem and the things that we've tried to do historically. Of course, in both cases, we want to talk about the technical requirements for deacidification. We also want to talk about the process safety. Those two have to go hand in hand. So in the case of the technical requirements, the first one, of course, is that we need to neutralize acid. You may know the expression, right? Acid plus base gives you salt and water. Well, in this case, we mean acid and base. We mean the base is an alkaline material. And when we say it makes salt in water, we don't mean salt that you eat. We mean that you've converted the acid into a compound that is neutral. It's not going to hurt the paper any longer. And so the point here is to make sure that we find a way to neutralize the acid into something that's going to be neutral to the paper. To do that, we want to raise the pH. Usually the right number is 6.5. If we get above 6.5, the reactions that are causing the problem with paper stop. Normally, if we use acid and react with the chemicals in Bookkeeper, we see a pH above 6.5, usually in the 6.5 to 8.5 region. It can be even higher, but that's enough. If we get into the 6.5 to 8.5 region, then we know we've done our job and we can make sure that the paper is going to be stable. The other thing we want to do is add an alkaline reserve to the paper. And by that, we mean that it's not enough to simply neutralize the acid that is there. We know that acids come to paper, not only after they've just been made, but by the way they're used, by the way they're stored, what's next door to them. So what we want to do is put into the structure of the paper alkaline material in excess of what's needed to neutralize the acid that's there. We call that an alkaline reserve. And that's because when future acids come to that paper, we want to make sure they can be neutralized. If we do that right, we'll put in enough alkaline material that you'll never need to treat this paper again. It'll always have additional alkaline material in it. So that's the goal, is to neutralize the acid and to put in enough alkaline reserve to protect the documents. Of course, we want to have a uniform treatment, and part of the ISO standards for deacidification is to look at pages in the textbooks that you treat, or in the documents that you treat, or the newspaper that you treat. Divide those into sections and make sure that you get relatively uniform treatment throughout the books and the documents. Of course, it goes without saying that we don't want to do harm to the treated items in the process of trying to solve the acid. So we want to make sure that we have good, effective treatment that's safe for the documents and that we're handling. So we're going to talk about 4 technologies as a way of dealing with the problem of acid in paper. Those are based on water-based methods, traditional, gas-based processes, non-aqueous solvents, and then Bookkeeper. If we look at water-based systems, it's a very traditional method. The conservators that are listening, you know, understand this very well. It washes out the acids. If you can immerse the documents in the water, you can wash away the acid. It helps to clean the documents. It adds some flexibility to the fibers. There are many advantages of being able to wash the documents. You can leave behind some alkaline reserve by doing that, although it's a little more difficult. And it's a very safe procedure. So you can do this in your lab, and there's no particular safety precautions that are of a concern. But you also know the difficulties of this. You have to be very careful in testing your documents before you put them in the water, because water can, of course, affect many things, inks, colors, or adhesives, depending on the susceptibility of the document you're treating. It can, in some cases, change the size and the feel of the paper. When paper becomes wet, when cellulose fibers become wet, they swell. And then when they dry again, they shrink back in size. And if they don't shrink back the same way they expanded, you'll get a cockling in the paper. And so it's important when you do this well, and conservators know how to do this, but you need to dry the paper carefully, often press it, make sure that it doesn't change in size. As a result, it's a bit labor intensive and time consuming to do this well. And it's a process that really isn't suitable for bound materials at all, or for large scale mass operations. For the description that we heard earlier about all the material coming into the archive and trying to deal with deacidification before further handling and processing, it's very difficult because of the time consuming nature of dealing with the large amount of material that's coming in. Gas processes are something that were talked about in the 1980s, 1970s, and 1980s. The Library of Congress spent a considerable amount of time trying to develop a process called diethyl zinc. And the idea was that you could take large amounts of material and put them in a chamber, and you get and expose them to a reactive gas that would neutralize the acid in the paper. It would not be labor intensive, and it should give fairly uniform treatment. The problem was that they found it was very, very difficult to control the reaction between the diethyl zinc, between the gas and the acids in the paper. The gas itself would react violently even with water, and so it was important to reduce the amount of water in the documents and the books or papers, whatever you had, down to a level of about 1% or less before you began treatment. Paper, cellulose often has 5 to 10% water in it, and so pulling it down to 1% on the paper itself can also affect leather and other kinds of materials that you want to put in here. If you don't do it correctly, then it becomes too hot. Everything gets very hot. This process was tried.
Excuse me, Mr. Bird, your connection. Yeah.
Yes.
Your connection is slowly connection for the USA. Maybe your Wi-Fi or something, because in here the connection is very limited. Can you hear my voice?
I see.
Okay. Good.
Okay.
Yes.
Okay.
The floor is yours, Mr.
Okay. I can hear and see you. Okay. Is it coming and going, or is it? It's okay now. Okay. 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 Thank you. So this was tried by the Library of Congress, the Swiss National Library, the National Archives of the Netherlands, but they all abandoned this process in the early 1990s because it was not safe, the kind of material that they were trying to treat. Solvent-based processes are non-aqueous, no water involved. They use a solvent that gives you a relatively uniform treatment. They can treat large batches at one time and not very late. Solvents are gulp. Yes. Okay. Yes. Hello. Okay.
Okay.
Yes,
I hear you.
Yeah. So for non-aqueous solvents can affect the inks and the dyes and the colors and the bindings. Most institutions that have tried solvent-based processes find that 3 to 5% of the material that they would like to treat is not suitable, especially if there are stamps or colors or inks associated with it. The other problem is that in the case of the reactions, what is produced is not salt and water, but they have a reaction that produces alcohol. So ethanol or methanol or propanol. And the problem is that material stays behind in the paper, and you have to 3 to 4 weeks. Feel free to. Hello, I can hear you. Yes, hello, I can.
Excuse me, Mr.
Are you still frozen?
Yes, but your connection is slowing down a little bit slowing down your connection.
Okay. I'm not doing anything at my side, so I'm not sure.
But now it's okay. It's okay. Your connection is good now.
Okay. Okay. I apologize for the technical problems. I don't have anything at my end to adjust. I was saying in the case of the Swiss process, it can take 3 to 4 weeks to get the odor of the alcohol out of the documents once they've been treated. So it's not very suitable in most cases if you want, and it's also, again, a hazardous process. So this is something that you need to operate as part of a chemical plant or a very safe environment. So what's different about the Bookkeeper process? We'll go through this in some detail so that it's clear why we've gone down the technology path that we have. But first of all, we always talk about process safety. The chemicals we use are not flammable, not toxic, they're not hazardous. They don't have any odor associated with them, and they don't make any hazardous byproducts. So we don't see alcohol, for example, in the paper when we're done. We don't create any waste products that need to be thrown away with special treatment processes. Of course, we don't use any water, and we don't use any solvents in our process. So process safety is really of the utmost importance to what we do. What we have found in our conversations most of the time is that first question is it safe? That's the question before we ask, does it work? Because we want to make sure that what we do does not harm the material we're trying to save. This is an old report, but the Library of Congress did a study in 1998 where the conservators of the Library of Congress tested the Bookkeeper process every way they could possibly think. They looked at the years of 1874 to 1990s. They looked at 2,000 different leaves of paper with 100 different types of paper. They looked at 100 different types of medias, inks, stamps, highlighters, colors. They looked at various bindings, cover materials, adhesives, fasteners, and put these all through their test to see if it was safe for the documents. And what they found was that all of these types of material were safe to use with the Library of Congress material, with the Bookkeeper process. They tried to find things that would be solvent in the process and couldn't find any. So they feel very safe about the kind of material that they send to us to treat or the kind of material that they treat in the library itself. The Czech Republic did a study, the National Archives in the Czech Republic did a study because they wanted to see how safe the process would be. The document on the left has been treated by Bookkeeper. It has so many different kinds of inks and colors and stamps, reds and blues and blacks and underlines, and none of that was affected in terms of the treatment. If you look at the document on the right, they cut this one in half and they treated the side on the right and not the side on the left, and they could find no difference in appearance for these two documents. These are documents that routinely give problems if you use a solvent-based system. So what's different about the Bookkeeper process? First of all, treating formulation is a suspension, which means we start with solid particles. It's not a gas or liquid that's the key ingredient here. We have microscopic solid alkaline particles. John Beatty will go into more details about these materials. But the point is that we're using solid particles instead of harsh chemicals to deal with this. And we suspend it in an inert, non-aqueous fluid. This is a material that's used in very high-tech applications. It's used in cooling supercomputers, in the production of microchips, and military applications. It really is super safe in terms of not affecting the material that you're treating and not causing any hazardous conditions. And the way it works is that we suspend the particles in this fluid. As you can see it being poured in, it looks a little bit like milk, the white particles in the clear fluid. The particles cling to the paper and absorb the acid. These particles have a very, very high surface area. And that surface area means it has a static charge. And the static charge helps pull the particles into the structure of the paper and attach to the fibers. The high surface area also means that it's able to absorb the acid very rapidly in the paper. So it serves two purposes. So the fundamental difference with Bookkeeper and all these others is that we use solid particles, we deposit them in the structure of the paper, and we let them absorb the acid. The question is how? So there's several ways. One way is to simply spray this material onto the material you want to treat. So in this case, the woman is using a spray gun to apply the Bookkeeper chemistry directly to a piece of newsprint. What you should notice is that there is no special safety precautions. She's not doing this in a laboratory hood. She's not wearing any gas mask or facial protection. She's not even wearing gloves. This material is quite safe. You can dip your hand in it. There's no odor associated with it, and it's not toxic. So it's important to understand that this is about the safest kind of treatment that you can make with your documents. This is a very short video, and what you're going to see I'm sorry, that shouldn't be you shouldn't be getting any sound from that. Okay, that was a bit fast, but what happened was that this woman spraying the piece of paper took a piece of acidic paper and sprayed it and covered half of it and sprayed the top half of the paper. And then she has a pH sensitive dye in it and marked the paper. And so this is the mark that she made. You can see the purple on the top indicates that that's an alkaline material. The yellow on the bottom shows you that it's an acidic material. And right where she stopped spraying is where you see the change. So what we're accomplishing is by spraying. It's a very powerful technique. Hello?
Yeah.
Hear me?
Yeah, I can hear you.
Okay. So it's a very powerful technique.
Yeah.
The next version of this is that we have an automatic spray system that we've just developed. So the spray tank and the spray system is now inside of this equipment. You can place documents, newsprint, a variety of material on the top, up to about A2 size, and select from the screen what you want to treat. So how much you want to apply and what size paper you're going to treat. So it's highly automated. It can be run by a technician without very much training. And this is a more uniform way of applying it. So this is our newest system that just recently been developed. The other thing you can do besides spraying this material on is to actually dip your material into the solution. A bath. Hello. Yes. Hello. Are you able to see the screen now?
Yeah, a little bit for your connection before, but now it's okay. Your presentation only has 15 minutes left for the 10 minutes left. Yeah.
Yeah, right. Okay.
Yeah.
We're good. Okay, so we're going to agitate in a bath of suspended solids. In this case, we have a vertical cylinder. You can see the books on the holders. We hold the covers loose because we wanted the paper in the book until we covered the material, and then we were ready to agitate. It means we raise the books up and down, and we have some spray nozzles from the side. The idea is to expose the pages to the treating chemicals. We can control the amount of time they're exposed, and we can control the concentration of chemicals so that we get the treatment that we're trying to achieve. We also have a horizontal treating vessel. And in that horizontal treating vessel, we can put very large books and newsprint. Here's an example of putting documents into a folder. And then we put those folders into a chamber. We fill the kit with the chemicals, with the treating chemicals as well, and we're going to agitate these back and forth. The same principle applies. We want to expose the documents to the treating chemicals so they can absorb the particles. So now we have a way of solving the problem, and we want to know about establishing the program. One of my favorite quotations is that preservation is a question of management, not of repairing, from Renee Tiger. You know, it's important that we understand that we're not trying to keep paper, we're not trying to make the paper stronger. We're trying to keep it from getting any weaker than it is. We're trying to stop the process where it is in its tracks. But what we don't want to do is wait so long that we have to either repair or digitize or can't use the documents the way we want to. So de-acidification is an active preservation tool. It means that we have to go out and make it happen. So who is doing that right now? Well, there are 10 installations of our mass treating system around the world, in Europe and in Asia and Africa, and the latest in the Middle East. National institutions are doing this all over the world as well. So we know about the Library of Congress. We know about the libraries in Canada that are doing it, and also in the Netherlands, the National Archive was the first international application of this back in 2000. The national libraries in France and in Poland, in Japan, and South Korea, and our newest is the Qatar National Library, where we just opened a new plant in January. So that plant is owned and operated by the Qatar National Library. So far in our history, we've treated more than 7 million books worldwide, more than 50 million documents, manuscripts, newsprint, government records, periodicals of all kinds, comics, all kinds of paper-based media. We've been found to be the safest possible process for doing this, the most effective process for doing that. So when we look at Bookkeeper, our goal has always been to be first safe for books, safe for the people that are running the operation, safe for the library and the environment, safe for the users. Second, to be effective, so that what we know is that with the proper treatment, these books will last 3 to 5 times longer, which means hundreds of years of life that we're giving to these materials. And that's why I think you'll find that Bookkeeper so far is the world's choice. It's really the only mass de-acidification system in use around the world right now. That's pretty much the extent of my presentation. And the only thing I would extend is that I'm going to let John talk, and we'll answer questions asked afterwards. But I think it would be delightful if we could have representatives from the archives visit us in the United States, so you could see firsthand how all these processes work. So I'd like to extend that invitation as well. And I'll turn it over to John. Thank you very much.
Well, thank you very much,
Yes,
Jim.
thank you. Yeah. Okay.
So, Ahmed, I can start anytime.
Yeah, wait. Okay, thank you very much for your presentation, Mr. Bird. I'm sure that everyone here already are eager to ask questions regarding the presentation. For those who want to ask questions to Mr. James Bird, you can type your questions at the Q&A channel below. Untuk peserta yang ingin mengajukan pertanyaan kepada Mr. Bird, silakan ketik pertanyaan Anda di channel Q&A dan pertanyaan akan dibahas nanti dalam sesi diskusi. Dari pemaparan Mr. Bird selama kurang lebih 40 menit tadi, saya mencatat poin-poin penting, antara lain Pertama adalah proses deasidifikasi tidak dapat memperkuat kertas yang sudah rapuh oleh pengaruh asam. Cara ini hanya dapat menghilangkan asam yang sudah ada dan melindungi kertas dari kontaminasi asam dari berbagai sumber. Metode Bookkeeper merupakan metode yang layak digunakan untuk proses deasidifikasi dan telah digunakan di berbagai negara di dunia karena metode ini tidak menggunakan bahan-bahan yang berbahaya, aman, dan mudah digunakan. Zat asam pada kertas merupakan masalah yang dihadapi oleh seluruh lembaga perpustakaan arsip di seluruh negara-negara di dunia. Untuk itu, sebaiknya kepada para arsiparis, pustakawan, dan staf di seluruh lembaga kearsipan dan perpustakaan untuk menyusun program deasidifikasi bagi koleksi bahan pustaka dan arsip, karena hakikatnya preservasi adalah bukan proses memperbaiki, namun merupakan bagian tak terpisahkan dari upaya penyelamatan bagi memori kolektif bangsa. Now, let's move to our second speakers. Hello, Mr. Betty. Good morning in Jakarta, good evening in USA. How are you today, Mr. Betty? Hello, Mr. John Betty.
Yes, hello.
Hello, how are you today?
Good, good.
Okay. Are you ready to share your knowledge and valuable insights to all archivists in all over Indonesia today?
I absolutely am.
Yes. Well, yeah, thank you. Well, before the presentation, I would like to introduce a brief CV of Mr. Betty. Kepada panitia untuk men-share screen CV-nya. Oke, Mr. John Betty, PhD, adalah manajer teknologi di perusahaan Preservation Technologies, PTLP USA. PTLP didirikan 30 tahun yang lalu untuk membantu lembaga kebudayaan, universitas, dan perusahaan swasta dalam melestarikan dan meningkatkan akses ke khazanah pustaka dan arsip mereka. Metode perawatan yang dilakukan adalah Bookkeeper Deasidification dengan tujuan untuk memperpanjang umur buku dan manuskrip dengan menetralkan asam berbahaya yang ditemukan di kertas dan the media preserve, melakukan pemformatan ulang film analog dan digital dan rekaman suara. Untuk tugasnya di PCLP secara keseluruhan, Mr. John Betty mengelola laboratorium penelitian dan pengembangan dan sistem manajemen mutu yang disertifikasi oleh ICO 9001. Untuk Deasidifikasi Bookkeeper, beliau mengelola lab control kualitas produksi deacidification massal dan produksi kimia Bookkeeper. Rantai pasokan bahan dan kontrol kualitas memproduksi produk Bookkeeper deacidification massal melayani 10 pabrik di 4 benua dan produk semprot atau spraying deacidifikasi yang didistribusikan di seluruh dunia. Sebelum bergabung dengan PCLP, Mr. John Betty bekerja di Universitas Johns Hopkins sebagai asisten profesor riset di Departemen Ilmu dan Teknik Material dan Konservasi Warisan Dokumenter di Departemen Konservasi dan Pelestarian di Perpustakaan Sheridan dan Museum Universitas. Dia telah menjadi ahli kimia di Administrasi Arsip dan Kantor Arsip Nasional atau NARA di Amerika Serikat, ahli kimia penelitian di Wilhelm Imaging Research Incorporation, dan asisten peneliti di Pusat Buku Universitas Iowa. Beliau meraih gelar PhD dalam kimia kertas dari School of Materials di University of Manchester, United Kingdom, dan menyelesaikan Andrew W. Mellon Postdoctoral Fellowship dalam ilmu konservasi di Universitas Johns Hopkins. Without further ado, Mr. Betty, the floor is yours. Yeah, Mr. Betty, the floor is yours. Now you begin your PPT. Yes. Yeah, Mr. Betty. The floor is yours, Mr. Betty.
Well, thank you very much, Ahmed. Distinguished attendees, ladies and gentlemen, I thank you sincerely for the invitation to speak to you tonight. I'm honored and I am humbled, first of all, to follow our company president in speaking and thinking what really I can add to such a complete presentation. But also to speak to you about some things that you know a lot about as an audience. I have spent my career in the preservation of cultural heritage materials with a focus on book and paper collections, as have, I'm sure, most of you. So hopefully what I'm about to say will be at least helpful, at least interesting, if not helpful. And then I look forward to our question and answer session when we finish. So I'm going to start the share screen. and also the slide deck. Okay. Ahmed, can you see my title slide now?
Yes, I can see your PPT now.
Okay.
Yes. Yeah.
So I've been asked to speak about the chemistry, about paper preservation, the science, and in particular the chemistry. And I want to provide a little bit of context for what I'm about to say by giving you my journey, in a bit of my journey in paper preservation, to give you an idea of my perspective and some of the realizations that I made along the way that are relevant to what I do now, and to this very important topic of protecting our cultural heritage. I first became aware of paper preservation science when I was obtaining my bachelor's degree in chemistry, where the introductory chemistry textbook, the general chemistry textbook, had an image of this distinguished gentleman blowing a brittle book apart. And now that I look at that, this is definitely a severe example of degradation, but not unlike some of the collections that we see at Preservation Technologies, where the paper is severely degraded. I later learned that this was Peter Waters, who was an official at the Library of Congress, who Jim had mentioned is our oldest and biggest customer for our deacidification processes. But what I realized looking at this image is this is exactly the kind of thing that I want to use my chemistry expertise for, not to work as a chemist to just synthesize plastics or whatever chemists are supposed to do, but to protect our cultural heritage. And so as it came time to graduate, I set it a goal to work at that time at the National Archives and Records Administration. I just didn't know how. But my first job was in industry, and that was just an excellent job to have. I worked at a private business called Wilhelm Imaging Research, where I worked under the Wilhelms, Henry and Carol Brower Wilhelm. The business is concerned with the preservation of photographic materials, and at the time, well, of all types, but at that time they were very interested in the inkjet prints and the light fading issues associated with inkjet prints. Those issues were addressed very quickly because the ink sets improved. They went to pigmented ink sets, and now digital printing with dye sublimation and UV curable ink sets have even further improved the matter. But what was interesting there was as those processes improved, the paper was sometimes the limiting factor in the preservation of the photographic materials. So just an illustration of how the preservation of paper, and I have many other examples which I wouldn't share tonight, is important to the preservation of all kinds of cultural heritage. I would notice also that images being built up directly on paper is something that we have seen before in the history of imaging, looking at this platinum and palladium print, which is an example of one layer photography. Following Wilhelm Imaging Research, I decided to work in book and paper collections at the University of Iowa Center for the Book, where there is the opportunity to, there are some researchers there are faculty dedicated to this, courses to take, degree programs associated with the book and printing and binding and that sort of thing. When I was there, I was doing two things. I was taking classes and I was also studying the European books under the direction of Timothy Barrett, who is a distinguished paper historian and paper researcher. And as part of my time there, I went into special collections and Tim himself showed me an incunabula, an early printed book where the black text was printed, but the capitals and the paragraph markings were added in hand by red. And the book looked pristine, it looked new. So I thought, what a contrast to the condition that certain contemporary papers are in such poor shape. And so I was very interested to understand that. The University of Iowa Center of the Book is in Iowa, of course, and so were the other two institutions I have mentioned so far. I went further afield to obtain my PhD in the chemistry of paper degradation. I went to the University of Manchester, UK, where I studied under Michael Sinnott. There, I wrote a PhD dissertation wanting to be as rigorous as possible about what is the chemistry of paper degradation in the library, the museum, the archive. And to do so, I did chemical model studies, looking at the chemical pathways of the degradation that we would expect to see under ambient conditions, the library, the museum, the archive. And I won't speak any further about this except to say that it definitely will inform much of what I'm going to present on tonight. After that, I realized my goal to work at the National Archives in Washington, DC. And I was a chemist for them and was involved in quality control of materials that were used in conservation, in holdings maintenance, and in exhibitions. This is depicted here as the exhibition space, the rotunda of the, I think it's 700 Pennsylvania Avenue on on Pennsylvania Avenue anyway in Washington, DC, where the Constitution of the United States and the Declaration of the US as a Republic independent of Great Britain are stored. But the National Archives has quite an active exhibitions, holdings maintenance, and conservation program. So there's a lot to do in terms of assessing materials. And this process of quality control is central to the work that I do in preservation technologies today. Following my time at the National Archives, I went to Baltimore, Maryland, and Johns Hopkins University, where I launched an academic career and resumed research more intently than I was able to do at the National Archives. And among the interesting things that I was able to do at Johns Hopkins was to build to be involved in the building of a laboratory space that was a collaborative space between scientists and conservators. And this key here depicts where the conservators work, designated by hearts, and the scientists. So a very collaborative space and a wonderful opportunity for me to see how conservators in particular, but also archivists and curators work and use archival and library materials. And following my time at Johns Hopkins University, I joined, and this was winter 2015-2016, Cranberry Township, Pennsylvania, which has been a real challenge of growth and responsibilities, and just a great company to work for, to be able to explore these very important topics of and be able to take action to protect paper-based cultural heritage around the world. And naturally, I work primarily within the Bookkeeper products and services. So the chemistry and science of paper preservation. I'm not going to spend, so that's of course a broad topic, a very broad topic, and I'm not going to spend much time to contextualize that. You are familiar with the work of individuals such as René Techler and others that contextualize that. But I do often think of paper degradation in terms of physical, biological, and chemical modes, which of course have some bearing on each other. There are microbes that do physical damage, for example, or they leave waste that does chemical damage to paper and so forth. The area that I'm going to speak about most is sort of on the interface between chemical and physical processes of degradation. Now, before I get into specifics, because we're just a little over 10 minutes in, I do want to do a little bit here in terms of contextualizing, which I hope is pretty helpful. I want to look at Dard Hunter, the American historian, and Roycrofter's definition of paper, one that he had shared with others, because it's actually quite modern. One of the departments that I worked with at Johns Hopkins University was the Department of Material Science and Engineering. It was in the engineering school, so I was not in the chemistry department there. And their department is concerned with materials and in particular their structure, processing, and performance. And we'll see a lot of that in Dard Hunter's definition of paper, which will get us a solid basis of the material of paper on which to talk about some interesting things about degradation and preservation. The first requirement is that the material be of plant origin. So this excludes sheeted material from skins like parchment and vellum. It also excludes, to be timely here, the respirators that we are all wearing during the COVID era, which may indeed have some paper content, but generally they are a synthetic material, a spun-bonded polyester. And that really is it in terms of the source. Hunter and others go on to define paper based on the process by which it's made, where the fibers are separated completely, or also known as macerated, excluding some other materials like papyrus, like birch bark, and other which are materials which I understand are also present in Indonesia, all of which have the interfiber relationship from the original plant still intact. Another definition is that the fibers need to be mixed with water or pulped. And this gives us an opportunity to talk about a very modern material that we don't classify as true paper because they are not processed in water. These are materials that are used for paper towels, for feminine hygiene, for chemical spills, and are very absorptive materials because they are not processed in water, called airlaid. These materials, these fibers are now collected on a sieve-like screen, which excludes the paper wasp's nest, which is not collected in that way. And then that stratum of fibers is usually pressed and dried. So the structure of paper, by definition, continues from the molecular level all the way to about a millimeter, which is the length of your average paper-making fiber. Some fibers are longer, some traditional fibers are longer than that, but that's sort of a length of a machine-made fiber. The effects of pulping, however, go right down to the molecular level, affecting the composition of the fibers which originated as plant cells and going right down to the molecular level, which I will explain in a minute. So if I want to look at what the chemical composition of paper is, as a chemist, I'm interested to know what is in it. And the molecular composition includes water, The behavior of water in paper, because it's been processed in water, is fascinating. And there's a wonderful book out by Gerhard Barnick and Irene Bröckler describing water in paper specifically for conservators and conservation scientists. It includes lignin wherever the paper is sourced from plant-based material that contains lignin. A wood cell being an example of a plant, a fiber source that contains lignin. This lignin, however, is reduced as a result of pulping. As pulping goes along, this amount of lignin is reduced, sometimes really down to just about nothing, as we will see. And the motivation is it discolors, it can be acidic, it's very poor component in paper, and you remove it if you can. Paper also includes hemicellulose, which are complex sugars, so polysaccharides or oligosaccharides that are outside of these micellular strands that are made of pure cellulose. These also are removed preferentially during pulping, as you can see also in this chart. The hemicellulose stays intact, a little bit better, but certainly a fair amount of it is removed, especially in the initial pulping process, which leaves cellulose. Cellulose, which we saw in that fibrillar structure, is responsible for a paper's strength and often the bulk of its substance. In fact, certain papers have been developed with the aim of being as 100% cellulose as possible. These are very chemically inert, and so they are used for scientific applications and also for healthcare. So I'm going on to talk about the relationship, a specific example where, because cellulose is so important to paper, as Jim mentioned, when we look at brittleness, we are looking at some particular relationship between physical and chemical degradation of the cellulose. As a result of pulping, or as a result of pulping, the fibers are left changed but intact. This macromolecular structure, which is how the strands interrelate to each other, is left largely intact in paper. And the molecule of cellulose, which, as Jim explained, is a chain, is also left intact to some degree. And Jim mentioned absolutely correctly that in a machine-made paper, they can be somewhere on the order of 1,000 of these sugar units linked end to end. But what we do see is this sort of relationship between the number of sugar units. If we lose sugar units in pulping, again, that's one of these loops here. We see that the strength goes right down when we go down to about 400 of them or so. This is tensile strength, which regards the strength of a paper when tension is applied to it, but it also applies to other physical processes. So what we're looking for with paper degradation is this molecule, as Jim mentioned here, splitting apart and reducing the total number of cellulose units in the chain. The question then becomes, how does that happen? And I'm a scientist, right? So I do a very rigorous assessment of all of the opportunities that there are for, for the paper to degrade, for cellulose to break, the cellulose chain to break. And there are a couple of ways that you can look at this experimentally how the cellulose chain breaks. If you are doing a very simple molecular study and you can measure the concentration, the initial concentration of your cellulose, say your small model for cellulose, and at a certain time, you can calculate a rate constant. And then under other conditions of more higher pH, lower pH, you can look at how those rate constants vary. An interesting process that people have done, because we work with actual collections, they are complex chemically. What we can measure is something called the degree of polymerization, which is actually, I could just say, instead of the number of sugar units, I could say instead the degree of polymerization, 1300 down to 200 degree of polymerization. And just substitute the concentration for the degree of polymerization initially at the beginning of the experiment and at the end of your experiment, and then you have a rate constant to compare it to other conditions. So I want to speak about iron gall ink here. And first of all, what this is, I understand that this is a document that is from your collection. What iron gall ink is gallic acid and iron 2 sulfate coming together to form this very black complex here, iron 3 pyrogallate. I'm sorry, I'm speaking quickly. I will slow down a bit. And that promotes oxidation. And in how it does it is it forms a lot of free radicals. So this iron 2, did we see the iron 2 there? Yes, so this is really an equilibrium with iron 2. In the presence of oxygen can form a free radical. It can react with the cellulose itself. This is R meaning an organic molecule and form free radicals. It can form an oxidative compound, peroxide. I'm sure you're familiar with it. From here too, we can form a couple of other free radicals and also this acid, this organic acid. So just to give you some perspective, free radical compound, flame combustion is a free radical mechanism, which gives you an idea of how dangerous free radicals are in the library, the museum, the archive. So this is one of the ways that cellulose degrades. Let me look at a couple of them that are less likely. People talk, and this is in particular because our approach is to add base, to add an alkaline material to the paper. And so there are some mechanisms that you can draw for alkaline degradation, including this one here. I have this one and I have another. First of all, some observations. This would be able to break the chain at any point because the cellulose chain breaks here. Actually, this seems to be a model study. So this is a model for a longer bit of cellulose. But this should be able to break the chain at any point. But what it does require is that you pull that hydrogen off. You have to ionize this group, which is very hard to do. It needs to be so alkaline that you pretty much have to add bleach to do it, far beyond a magnesium oxide particle. Also, it produces various products that we don't see evidence of in paper. Here's another mechanism just quickly. And the same thing here. This mechanism could break the cellulose chain at any point in the chain within the 1,000 units. But again, it requires the ionization of this hydroxyl group to just pull that hydrogen right off, which is very difficult to do and needs to be extremely basic, pH 14 or so. And it also produces molecular evidence of materials that we do not see in the library, the museum, the archive. Note here that this mechanism and the one before it are sometimes, I don't know if they're trying to call this one alkaline hydrolysis, but these are not a hydrolysis. They do not involve water, at least in the mechanism. Okay. There is a mechanism of degradation in alkaline conditions called the peeling reaction. Observations about this mechanism is that it can occur because it's resonance, there's no intermediates that are difficult to stabilize. It can occur at pHs lower than 13, but it can only remove one unit from the end at a time. And in fact, it has a stopping mechanism here, which I will not go into, but it leaves you with this particular end. So this R connects to the rest of the cellulose chain, which cannot undergo further peeling. So we move on to the mechanism, the primary mechanism of degradation, the acid catalyzed cellulose hydrolysis. And this also can break the chain at any position. And it's catalyzed so that the proton, it connects to this glycosidic oxygen, this particular oxygen atom, as Jim had mentioned, and then it diffuses away. So it's a textbook catalyst. This hydrogen atom now, this proton, this acidity is able to catalyze the next degradation of cellulose, so on and so forth. So we do know that the breaking up of the cellulose chain is due to low pH acidity. And I was skeptical about this. So one of the things that to know whether this was the case, because one of the things I wanted to look at during my time in Manchester was rosin alum sizing. Rosin alum sizing was the first industrial sizing. And it uses the aluminum-3 ion to coordinate the cellulose to this rosinous acid that achieves the sizing. And that aluminum-3 ion is acidic in water. It produces acidity. And so I speculated that a metal could break the cellulose. So this was a model compound that had a part that looked like cellulose. Perhaps it could break a model that mimics cellulose for both rings. So this is something I did when I was in Manchester. This is the model compound that we used. And we found that this mechanism itself is pH dependent. So as you increase the pH, and this is the rate constant, the rate becomes lower and lower and lower. Okay, so the answer is to the vast majority of issues with paper degradation is to add a base. Okay, further evidence of the importance of acidity is from the structure of lignin, which has a couple of different units that can readily oxidize to become an organic acid, a carboxylic acid. Hemicellulose, as well, one of the most important hemicelluloses in softwood, is galactoglucomannan, and it has acetate groups that can pop off according to a chemical mechanism that's called the Fischer esterification and form acetic acid, also known as vinegar. Iron gall ink, while it has those really important oxidative mechanisms, also is acidic. Gallic acid itself is acidic. It has that carboxylic acid here, and it does coordinate in the complex, but you are left with two molecules of acidity here. And given that this iron is commonly introduced as iron 2 sulfate, you're left with sulfuric acid generated when you produce iron gall ink. Similarly, what we noticed in these mechanisms of oxidation is that acidity is also produced. So increasing the pH by adding a base helps iron gall ink collections as well. Also important to promoting cellulose hydrolysis is water, the presence of water. This has been supported by a number of conservation scientists, René Techler for one, and also Chandra Shahani at the Library of Congress. And notice the involvement of water in cellulose hydrolysis. The water molecule has to be connected to this carbon atom when that proton alights onto the oxygen atom. So, and because water is only 4 to 6% by weight, the more water you have present, the more likely that water is going to be in that exactly the right place. Okay, so to conclude the part one, and then I have for my remaining 12 minutes, I have a very short presentation. I want to underscore really what Jim Bird has already said, that acidity is the #1 cause of degradation in paper collections, and that the presence of heat and humidity make degradation worse. Okay, so just pause to take a sip, and then a very short presentation given.
Okay. Thank you very much for the presentation, Mr. Betty. There are so many new interesting information that you explained in the last 45 minutes or less 45 ya. Dari pemaparan Mr. Betty selama kurang lebih 45 menit tadi, saya mencatat poin-poin penting, antara lain zat asam pada kertas adalah penyebab utama kerusakan pada kertas, terutama untuk keasaman arsip dan koleksi buku di perpustakaan. Faktor cuaca membuat kondisi kertas lebih buruk lagi. Okay, Mr. Betty, you can continue for your PPT or?
Okay, yes, I just had a, yeah, I guess I don't know if the presentation was stopped. I just had a brief, less than 10-minute presentation to conclude with, and that is, how do you do deacidification right? And once again, my perspective as a chemist is what is in the deacidification, what's in it. So what we do at Preservation Technologies in Bookkeeper is we add the magnesium oxide compound, which, as Jim mentioned, is safe to humans. In fact, it is a supplement. Sometimes it's called magnesium oxide. Sometimes it's just called magnesium, but it's often 100% magnesium oxide. Now, how that neutralizes acids, I'm relying on the reference here of Havermans in a publication he did for the Netherlands Organization for Applied Scientific Research, TNO of the Netherlands. And he showed that, and others have shown this as well, that magnesium oxide reacts with organic acids and it reacts with inorganic acids. We see one reason why sulfuric acid can be present in paper. Another is, I mentioned aluminum-3 is acidic in water. Just to complicate that a little bit, aluminum-3, because of rosin alum sizing, was commonly introduced as aluminum sulfate, also known as papermaker's alum. And so you do get sulfuric acid as a result of that. Now, the magnesium oxide, I said, was the correction. The magnesium sulfate is the product here. Even the product is safe for humans because the magnesium sulfate is often referred to as Epsom salt. Back to the deacidification agent, magnesium oxide. As Jim mentioned, our particle has a nanostructured surface with an ultra-high surface area of 100, in this case, generally around 180 square meters per gram. So this is an interesting mathematic problem for those of you who are very interested in it. Ours is a very rough surface, but if you calculated the size of a particle that had that kind of surface area per gram, using the equation for the surface of a sphere, the volume of a sphere, you would come with a diameter of 20 meters. So, correction, 20 nanometers. So ours is a nanostructured particle. The magnesium oxide does not stay still in paper. It reacts with water vapor to form magnesium hydroxide. It reacts with CO2 in the air to form magnesium carbonate. And magnesium hydroxide also reacts to form magnesium carbonate. So we expect this to be a very significant deacidification agent in our process after time. Similarly, magnesium carbonate is a safe material because it is used for gymnastics, for example. Our carrier fluid that we use, Jim has described, we use perfluorocarbons. Liquid breathing is still a thing for movies. I think people are looking into liquid breathing. People can breathe in, but breathing out is difficult. But it is being used for treatment of the lungs of premature babies born premature who unfortunately have developmental lung problems. This image here is of a baby's lungs that is full of perfluorocarbons. So a very safe material to be using for deacidification. Perfluorocarbons, testing with sensitive medium. Has my PowerPoint not played this whole time?
Yes.
Oh, I do apologize. I
share screen.
See
You're
that
not.
it was.
Yeah.
Wondering what the situation was. Okay.
Here
Yes.
we can to see your presentation before.
I am having some problem. I've got numbers. I've got that screen, the number. Okay. So good. I press the share screen button and it doesn't seem to. Oh, okay. I just didn't press that last.
Yeah.
So I'll make it very quick.
Yes.
Okay, so I'm going to, thank you for the interruption. I'm going to make pretty quick work of this in that case. Again, I'm going to try to start here. I'm going to, I guess, stop the presentation. And then I'm going to start back here. Okay. So can you see this now?
We can see
the question.
Yeah.
Okay, so the question was how to do deacidification right. And then I mentioned that what's in it is very important to me as a chemist, that I work for Bookkeeper. And then I talked about how safe the magnesium oxide particle is, that it's used as a nutritional supplement. And then I looked at the chemistry and, you know, I was able to say this orally simply that the magnesium oxide reacts with organic acids and inorganic acids, and had this illustration of where sulfuric acid comes from with rosin alum sizing. And going back to this magnesium sulfate, that too is safe because Epsom salt is used internally and externally. Here was the illustration for the ultra-high surface area. I don't have the mathematics here, but it's a fun problem to work out, where you can calculate that a smooth particle having that same surface area per gram is 10 nanometers. Here is where we get the magnesium carbonate as the final, as develops over time. Our magnesium oxide develops through a couple of mechanisms to get to magnesium carbonate. Its safety to humans being used in gymnastics. And here are the illustrations of liquid breathing, which does not take place. It's just items for movies. But in the case of premature births, it is actually used, and this is an image of perfluorocarbons being used in a premature baby's lungs. Okay, as far as testing, so this is where I was. So I'm now caught up, I think. Bookkeeper for use in single item treatments. This is the Library of Congress publication that Jim was speaking about, and he mentioned some of the things that they were able to conclude. I'll just highlight here that with the approximately 100 various media papers were represented, no evidence of alteration to any of the media or paper types was observed during any of the spot testing treatment. And they went to talk about specific collections, no evident alteration of media paper. No evident alteration of media paper in this collection and in this collection. But we still continue to test media. We're testing media all the time. We publish on the topic and disseminate on the topic. And just to conclude about our fluid, it's just to prove that it's so much better than so many others. Well, first of all, water definitely has a place in conservation. I'm not going to argue that, and Jim talked about the specific instances, the benefits of water. but also the problems with water, especially when one tries to use it for bound volumes. Okay. Some of our competitors try to use hydrocarbons. We have a competitor that uses heptane. And of course, that's just one carbon away from octane, which is your rating on the performance of gasoline. Not very good. It's not a tremendously good solvent, but it is not good for paper-based collections in many cases. Similarly, siloxanes. Jim talked about the odor. We have a competitor that uses the odoriferous and hazardous siloxanes as a carrier fluid. Each of these, require that the competitors' work is done in secure facilities that are away from the archives. So the conclusion for part 2 is that a deacidification product must perform. It must neutralize acids and leave an alkaline reserve. In addition, Bookkeeper deacidification is the safest for people and on collections, making it the only option for on-site use. We have this spray system that Jim mentioned. We have the new advanced spray system that is now available, but it can also be used at this very, very small scale that can be brought in to even a very small archival space so that it can be used while the scientists are working, the conservators are working, the curators are working, and all of those with whom we work on a daily basis to protect our respective nations' cultural heritage. Thank you.
Okay, thank you very much for the presentation, Mr. Betty. There are so many new interesting information that you explained in the last 45 minutes. Dari pemaparan Mr. Betty selama kurang lebih 45 menit tadi, saya mencatat poin-poin penting, antara lain zat asam pada kertas adalah penyebab utama kerusakan pada kertas, terutama untuk Keasaman Arsip dan koleksi buku di perpustakaan. Faktor cuaca membuat kondisi kertas menjadi lebih buruk lagi. Dalam melakukan deasidifikasi harus dilakukan secara hati-hati karena deasidifikasi yang tidak tepat akan menyebabkan kerusakan pada kertas. Gunakan teknologi Bookkeeper untuk melakukan proses deasidifikasi karena metode ini menggunakan bahan yang aman seperti magnesium oksida. Teknik ini juga lebih mudah dilakukan bagi para arsiparis karena dapat dilakukan langsung di tempat arsip tersebut disimpan tanpa memindahkannya ke tempat lain. Wah, banyak sekali pengetahuan ya. Dan yang keempat adalah dalam presentasinya, Mr. Betty menjelaskan secara teknis bagaimana zat asam merusak kertas sebagai media arsip dan bahan pustaka dalam menggunakan ilmu kimia dan fisika, serta menjelaskan bagaimana teknologi Bookkeeper secara efektif dapat menghilangkan zat asam yang terkandung dalam kertas. Boleh beri tepuk tangan sekali lagi Bapak dan Ibu. Marilah kita masuk ke sesi diskusi dan tanya jawab yang ditunggu-tunggu ya. Pasti banyak yang ingin bertanya, dari chat juga cukup banyak. Jika ada yang bertanya, silakan menuliskan kolom chat Zoom dan YouTube, dan kami akan memilih beberapa pertanyaan dari Bapak Ibu sekalian. Jangan lupa menuliskan nama dan instansi Bapak Ibu sekalian sebagai penanya. Okay, before open the discussion session, as a moderator, allow me to ask questions regarding the explanation of the previous speakers, both from Mr. Bird and Mr. Betty. In the previous explanation, the chemicals commonly used in the deacidification process are magnesium carbonate and Bookkeeper. Magnesium carbonate is used in the immersion method, while Bookkeeper is used in the spraying method. The disadvantage of using Bookkeeper is that it's expensive and difficult to obtain, but its use is easy and practical. While magnesium carbonate is cheap, but its use requires time to be made in the form of solution with a certain concentration. What I want to ask, is it okay to use magnesium carbonate in the spraying method, and how does it affect the acidity neutralization process of the archive?
Well, I'll start, John.
Yeah.
If you're spraying the magnesium carbonate, you're
Yes.
doing it in a water-based material,
Yes.
right? Water-based solution. So
Yes, Mr.
you have the same issue with dealing with water-based processes. Trying to get a uniform application of it is not easy to do, and you still have to deal with the issues of solubility. It's not much better in many respects than doing the bathing process associated with it. The reason we use, of course, the chemical that we use, there's two things. One is that magnesium oxide that we were able to use has such high surface area. That's what John was mentioning. So a high surface area makes the absorption of the acid very, very uniform and very quick to occur. And also the chemical itself, of course, doesn't have any solvency. So the problem with the magnesium carbonate is exactly that. It's the water-based nature of it. It makes it much more difficult to do in a safe way for the documents.
Thank you, Mr. Bird, for your explanation. Okay, now Mr. Bird and Mr. Betty, we are now in the discussion session. The committee have selected some questions given by the participants. Kepada panitia untuk men-share screen pertanyaannya. Oke. Berikut adalah question list, daftar pertanyaan. First question. For Mr. James Bird, name Jasacom 9586. Can we use Bookkeeper to clean morgue and mood? Because we have jobs to serve the people. Actually, they have accidentally like flu, or they don't know to treat the archives. What is we do if we have accident like flu or have mold in our archives? Can we use channel for first step to clean the morgue and mood? Yep, Mr. James Bird.
Well, a Bookkeeper is not useful at all for cleaning material. The only thing it does is deposit alkaline particles to the paper. So in terms of this, you're left with a need, I think, to water wash to get rid of the mud and mold initially. If you treat with Bookkeeper, or if you raise the pH in general, that will help to slow down growth of mold. But if you have very humid and wet conditions, you need to deal with washing that off and drying it properly. So I don't think Bookkeeper is useful in this application. Once you have the material cleaned and dried, then it would be useful to put an alkaline reserve into the paper.
Okay, thank you, Mr. James Bird, for explanation. For next question, for Mr. John Betty, from Taufik, National Archive Republic of Indonesia. Beberapa negara telah mengembangkan bahan deasidifikasi dengan berbagai macam komposisi untuk memastikan bahwa proses deasidifikasi tidak akan menyebabkan tinta luntur dan sekaligus dapat memperkuat fisik kertas. Menurut Bapak, apakah pengembangan tersebut akan menurunkan optimasi proses deasidifikasi? Yes, Ms. Rini, you can hear in the interpreter channel. Yes, Mr. Vicky. Can I repeat the question or? Okay.
Okay, so I at first I understood the question as whether there were drawbacks in terms of the efficacy of deacidification if you were to add a strengthening component. But it sounds like I'm being asked to comment on strengthening in general. With that understood, having strengthening is something that we are working on. We do not have a strengthening product currently. When we come out with one, we will want to make sure that it has that same level of safety to humans and to artifacts that our de-acidification has. But I do understand that there is some benefit of strengthening paper in some cases. So I'll finish there, and if there's anything Jim wants to add, he sure can.
Yeah, John, I guess in terms of strengthening, if we think of what's happening, we've got the fibers that are breaking. If you want to strengthen the paper so that now it is strong again, you have to reconnect those fibers in some manner. That's not something that is easily done, or to our knowledge, it is really consistently done. If you add water to the process, the fibers can become more flexible for a period of time, but that doesn't last. So it doesn't give you an increase in strength that lasts. So we today don't know of any processes that give you a lasting increase in strength.
Okay, thank you, Mr. Betty and Mr. Byrne. For we get to the more questions. Next, okay, in the question 2, for Mr. James Byrne, name Rati Surtikanti from University of Indonesia. Are there differences in archive deacidification techniques based on the environment, such as de-acidification in America and Indonesia, which have different climates?
Yeah, that's a very good question. The short answer is that the procedure is the same, but you have very different climates. And so we know that what affects the strength of paper, what affects the attack of acid on paper, temperature and humidity can greatly accelerate that. So it's important to keep your temperatures and the humidities under control, but it's even more important to deacidify if in a situation as in Indonesia, if you have higher temperatures or higher humidities than we have in the US, it's even more important, because the most important thing you can do is to neutralize the acid to minimize that growth. Otherwise, there's not a difference in the processes. The processes are the same in both locations.
Okay. Yep. Thank you, Mr. James Byrne, for your explanation. One more question from Mr. John Betty, named Tias from University of Diponegoro. Unit Restorasi Arsip Nasional RI melakukan deasidifikasi terhadap arsip yang akan dilakukan laminasi or straightening treatment. Menurut Bapak, tahapan laminasi dilakukan ketika arsip telah kering setelah deasidifikasi atau boleh dilakukan saat masih agak basah, dan apakah pengaruhnya terhadap hasil restorasi? Ya. Thank you.
So I have studied lamination prior to coming to Preservation Technologies. At Preservation Technologies, we don't laminate documents. I am not a conservator or a curator. It's my understanding that the encapsulation process, for example, where a document can be placed between two sheets of polyester film, has essentially all of the advantages of lamination, but not the disadvantage of actually adhering the film to the paper itself as a laminate does. In what I had studied for the barrow process of lamination in particular, I understand that the laminated documents can be in very, very good shape, but that process depended on the documents being deacidified prior to lamination. And the reason I had mentioned in my talk that not only are acids, as Jim mentioned, absorbed from the environment, but they can be generated within the sheet itself. And if you don't first deacidify and leave a magnesium oxide component, and the acids are generated in the sheet, they will stay there in the sheet in higher concentration and do greater damage.
Okay, thank you, Mr. John Betty, for your explanation. We have more questions. Okay, in the question 3, for Mr. James Bird, name Yuanita Utami from National Archive Republic of Indonesia. Proses dekomposisi kertas melibatkan banyak reaksi kimia antara selulosa dengan reaktan lain yang biasanya dipengaruhi oleh kondisi lingkungan. Pertama, apakah deasidifikasi hanya dilakukan satu kali atau perlu dilakukan deasidifikasi ulang setelah beberapa tahun? Kedua, hal apakah yang harus diperhatikan untuk memperlambat laju reaksi dekomposisi kertas terkait dengan kondisi ruang penyimpanan arsip atau buku? Ya, silakan Mbak Rini untuk mentranslatekan.
That's a really good question, and it's a very important question because it's time consuming and takes a lot of effort to deacidify documents. So the answer is that no, this is a one-time treatment. So that once we've taken care of removing the acids from the paper, and the key now is to leave behind an alkaline reserve. So we want to leave enough alkaline particles in the paper that you never have to do this again. And when we put, John didn't describe it exactly, but we tend to put in a 1% alkaline reserve. And what we find is that 1% alkaline reserve is sufficient to deal with all the acids that's in the paper by a large margin. It's a very, very high margin. Is it possible for me to share a screen again with you? Is that not, can I do that?
Yes. Yes, I can hear your voice.
Yeah. Okay.
Okay. Thank you for your explanation, Mr. James Bird.
Yeah,
Are you
so-
finished your explanation, your answer? You're finished?
Well, I was going to try to share my screen for a moment.
Okay.
Are you able to see this graph that's on the screen right now? Okay.
Yes.
Okay.
Okay. Okay, we have more question. We have more question from the committee.
Okay, I'm sorry, it doesn't seem to work.
Yeah.
Well, what I was going to show you is that we can do measurements of how much.
Okay.
Yeah,
Oh,
okay.
Let's go to your share screen.
Okay, so that's what we do. Now it's clear. Okay. All right. So what I'm showing you is a test that's done. So in order to know if we've done any good, it's important to do what's called an accelerated aging test. We know that if we neutralize the acid in the paper, it's supposed to last longer, but how much longer? And did we put enough alkaline reserve in? So the test had been developed by the Library of Congress and accepted by the ISO Standards Committee is what's called a accelerated aging test. And this graph shows that if we start at the left side of the graph, it talks about what the paper is today in terms of strength. And this top line is a deacidified piece of paper, and this bottom line is a control, so not deacidified. And what we do is we take these papers and put them in a sealed tube in an oven, and we keep it for a period of time to see what happens as the paper ages. It has its own amount of acid and alkaline reserve, and we want to see what happens. What these charts are showing us is that if you don't deacidify, the paper gets weak very, very quickly. And if you do deacidify, then the paper stays strong much, much longer. And we look at the ratio between these lines, and we see that it will last 4 times as long. In this example, this paper will last 4 times as long because we neutralize the acid. And by the time this test is done, this paper is already very, very weak. And this paper is still very strong. It still has a lot of alkaline reserve. When we do the measurement, we see that we have lots of alkaline reserve still left. Now, this temperature was done at 80 degrees over a period of 60 days. So we can see that raising the temperature makes the reaction go much faster. The same thing happens in the library or your archive. If you raise the temperature, the reactions go more quickly. It's not 80 degrees, I know, but it goes much more quickly. But as an example, if we look at it, the same graph, and we do the same experiment, we're at 50 degrees. Instead of 80 degrees, we do 50 degrees. Now it takes a year to get down to the same kind of level. So you see, it takes much, much longer, but it's the same result. It's still 4 times better if you deacidify than if you don't. And when we get down to the end of life of this paper, there's still a lot of alkaline reserve left up here. So I wanted to demonstrate that there are tests that we can do to show that it works, that the process works. We can see the extension of life that we get, and that we can see that the amount of alkaline reserve that we put into the structure of the paper is sufficient for the life of the paper. You do it one time, and that solves your problem. Good. Are there questions for that? Is that okay?
Okay, that's okay, Misha. Thank you. Okay, we have more questions in the slide. Pada panitia untuk men-share slide yang tadi. Yeah, this is the question for John Betty, Yana Suryana from Andri. How to preserve paper archives that are affected by ink burn? Besides, we can do the acidification with Bookkeeper so that archives are not getting brittle.
Yes, so I'm going to assume that this particular ink burn that is being talked about here is the iron gall ink that I was in my presentation. As I mentioned in the presentation, the acidity component of iron gall ink is helped by Bookkeeper de-acidification. But the oxidative component that involves the free radical production is not benefited by Bookkeeper de-acidification. And so we are working on an alternative for that will be effective against the oxidative component, but we do not have it yet. As far as the recommendation, I know that there are definitely conservators that advise on specific procedures for that, certain things that can be done on single item treatments. But I am myself not qualified to advise on what to do.
Okay, thank you, Mr. John Betty, for the explanation. Okay, more question for Mr. John Betty from Michael William from UIB. What kind of difference that you get when you do quality control of paper preservation in conservation, holding, maintenance, and exhibition?
So the quality control that I do now is for the mass de-acidification process in our corporate plants in Cranberry Township, and also for our Bookkeeper chemistry products. I had done quality control for conservation, holding, maintenance, and exhibitions in the past, and that was when I was working for the National Archives. The difference between those is just the standards that they have to adhere to. Some standards would apply to for different purposes, but often for example, for an exhibition, the conservator would make a decision on what's important, and then it would be a quality manager's responsibility to make sure that the materials being brought in are tested to adhere to those standards. So I'm sure this is a process that goes on at your National Archives, the Republic of Indonesia, to make sure that the materials adhere to your standards. And in a similar way, it will depend on what they're being used for.
Okay.
John, can I jump in for 1 second?
Yes.
In terms of talking about quality control, I was going to add to what John is saying. I served on the ISO committee to develop quality standards for deacidification. And this is a bit different than the topic, but I want you to understand that in order to qualify as an acceptable deacidification technique, you need to go through many quality control tests with ISO to meet ISO standards. That means we have to start with individual documents, papers, types of papers, and put them through the process and demonstrate uniformity of treatment, uniformity of pH, changing the pH, the amount of alkaline reserve that is deposited. And then we have to do the testing we just talked about with the fold endurance testing and the aging. So all of those are done to qualify the process in the first place. Then there is a follow-on quality control that we do on a daily basis to check to make sure that the process is still treating paper properly. And for the Library of Congress, also a test book or test documents every week to demonstrate that with real objects that you're getting the right results. So there's a continuing quality control process to ensure that the process is working as it's supposed to operate.
Okay, thank you, Mr. Byrne. We go to the Q&A in the chat for this application Zoom. From Wahyu Marsudi Wibowo, Pusat Sejarah KNI, from James Ibert, how to treatment a newspaper collection in the de-acidification process. How to treatment a newspaper collection in the de-acidification process.
Okay, well, there are two methods. There are two methods. One method is to use the spray system that we've already described, so that you can spray sheet by sheet. That's okay, depending on the quantity of material that you have to do, because it's time consuming and it's more labor intensive to do it that way. If you have a very large quantity of material, then it's best to use that horizontal treater that I showed. The National Library in France, the Bibliothèque Nationale de France, sends a large quantity of newsprint to a plant in the Netherlands every year, for example. And so that's treated in that horizontal vessel in those containers that we showed you. And doing it that way, you can treat hundreds of sheets per batch. And a batch can take you maybe an hour or two to run. So you can do substantial number of documents of newsprint if you want to do it with a mass treatment like that. The advantage of the mass treatment compared to the spray product is that if the spray product, it's very quick, but it's labor intensive, and it also means you don't recover the chemicals associated. If you put the documents into the mass process, then you can recover the chemicals, because instead of evaporating through the air, we condense them and recycle them back into the process. So it's more efficient in terms of that. The equipment is more involved. It's a bigger installation. You need some more room, but it's more cost effective. So for large quantities of materials, you're better to use the mass process. For smaller quantities, then it's fine to use the spray process.
Okay, thank you, Mr. Weber. Next question for Mr. Betty, sorry. From Muhammad Ardi Kusuma, Lapas Kelas 2, Bance, Bandung. What motivated you the most to process the de-acidification into archive preservation, and to what extent state support for archive preservation? What motivated you the most to process the de-acidification into archive preservation, and to what extent state support for archive preservation?
So I understand the question was what motivated me to be involved in archives preservation in the first place, and then what was the second part of the question?
Yeah, the question is what you're motivated you the most to preservation into archive, and to what extent state support for archive preservation.
Well, this time, Ahmed, you were quiet.
Okay.
I think
Oh yes, I think you used for the interpreter third channel. In Indonesia, apa motivasi yang membuat Mr. Betty untuk melakukan proses de-acidifikasi, dan apakah didukung oleh di negara Amerika Serikat mengenai preservasi arsip tersebut? Proses preservasi arsip di Amerika apakah didukung? Apakah mendapatkan dukungan dari proses preservasi tersebut? Sedikit pertanyaannya, Mbak.
I'm not able to speak about the early days. On the second half of the question, I'm not able to speak about the early days of the development of the Bookkeeper process and the extent to which we had support from the United States in the beginning. From the first, which I will have to just defer to Jim on that one, as far as being motivated to work in conservation science and working in developing information, products, and processes that are useful to professionals working in the preservation of cultural heritage materials. I tried to express some of how that developed. I just have found it to be a fascinating topic. I have always been fascinated by being close to materials like paper that are able to convey artistic expression, historic communication through time and through great distances. And I'm just delighted to be a part of it.
I can answer the second part about the question.
Yes, Mr. Bird.
When we first started in 1992, very small company and just a couple of people. And we were able to obtain a low interest loan from the state government. Because we were a small business, innovative research, we were able to get a very low interest loan to help start it. But no other support from the government in that sense. We had to qualify under a bidding situation to have them try our process and to put us through those conditions. So we were fortunate to have access to some seed money to help get started, but that was really the extent of the government support.
Okay, Mr. Word and Mr. Betty, thank you for your explanation. Any question for Kodir, from Kodir, Perpustakaan Nasional, ditujukan untuk kedua narasumber. Pertanyaan yang pertama adalah, apakah gas yang dipakai untuk deasidifikasi kertas ramah lingkungan dan mudah diperoleh di Indonesia? Pertanyaan kedua, selulosa sangat disukai rakyat. Jenis selulose apa yang tidak disukai rakyat? Terima kasih. Dari Kodir, Perpustakaan Nasional. Yep, you can use the interpreter channel. Okay.
Yeah, I think I can say, first of all, for the deacidification component, magnesium oxide is what we use, of course, and I think that's one of the better agents that you can use, especially in this environment, because it has a good quality, a high pH value, can help raise the pH. pH is generally good if it's a little bit higher in dealing with mold. In terms of insects, I don't know of any kind of cellulose that can avoid the attack of the insects. John, do you have any sense about that?
Yes, I have actually not studied insects myself. We do have conservators who tell it, speaking about mold instead. We have been told by our users that Bookkeeper deacidification can slow, but not stop the growth of mold. And it's because, unlike cellulose, the magnesium oxide is not a good metabolite, not a good food for the mold. So we have done some studies and we would like to continue because we're seeing promising results that substantiate that to be the case, but we have not proven that yet.
Okay. Thank you, Mr. Betty, for your explanation. Next question is for the both of you. From Eli Sekar Ayu, Perpustakaan Nasional, for Mr. Bird and Mr. Betty. In our library, we still use aqueous deacidification and non-aqueous deacidification. Deacidification can maintain the pH of the paper for how many years? In what year should deacidification be repeated?
Yeah, that's the question we just answered, I think, with the showing the chart and the degree of preservation. If you put an alkaline reserve in the paper, then you never deacidify again. It's a one-time treatment.
Okay. Thank you, Mr. Bird. And Mr. Betty, can you explain for that question?
I have the same answer as far as whether the deacidification needs to be done again. So again, we deposit sufficient alkaline reserve not only to neutralize the acids that are already present in the paper, but for those acids that may be generated within the sheet or that may be absorbed from the environment. Was there another component, another first part of that question?
Yeah. Yes, this for.
It was about aqueous deacidification. The question about aqueous deacidification.
Aqueous deacidification. Aqueous deacidification and non-aqueous deacidification can maintain the pH of the paper for how many years? In what year should deacidification be repeated? I see.
Yes. So I'm not an expert on aqueous deacidification. But I think Jim and I both acknowledge that it can be used as far as ensuring sufficient alkaline reserve in aqueous deacidification. I would just say that the way to test alkaline reserve that we use for our non-aqueous bookkeeper process would also apply to the aqueous deacidification process as well. That you would want to do that with a test paper, however, because it is a destructive test.
Okay, thank you for your explanation, Mr. Betty and Mr. Bird. For the last question from Dewi Yulianti from Pusat Pelaporan Analisis Transaksi Keuangan to Miss James Bird in Indonesia, apakah ada waktu ideal atau frekuensi untuk melakukan deasidifikasi arsip selama setahun? Ya, Mbak Rini?
No. What you need to do is to begin a selection process to determine what is the most important material in your library or your archive, and to work with that material first. But it's so important to put in this alkaline reserve that we're talking about, because if you do that, then you do not have to do it again. So it's a one-time treatment, and because the book has so much acid in it, and we can put in an excess of alkaline material to take care of that. We know that that acids can come from external sources, but we put in a lot of extra alkaline reserve to take care of that. So if we do the alkaline reserve right, then you never repeat the treatment.
Okay. Thank you, Mr. Bird. Okay, well, now we are the closing session. To Mr. Bird and Mr. Betty, once again, thank you very much for all the recommendations, inputs, information, and knowledge for all of us today. It is too bad that the time is so short today. I hope that we will have another session to talk more about the certification for archive. Luar biasa sekali pertanyaan dan diskusi kita kali ini, Bapak dan Ibu semuanya. Sehabis acara ini, sepertinya Bapak dan Ibu menjadi tidak sabar nih untuk melakukan uji keasaman pada arsip kertas yang Bapak dan Ibu miliki nantinya. Dikarenakan keterbatasan waktu, kami harus sudahi diskusi kita pada hari ini, dan sebelum acara ini ditutup, saya ingin meminta kepada kedua narasumber kita agar dapat memberikan pernyataan penutup atau closing statement terkait tema kita pada hari ini. As the closing statement, I would like to invite Mr. Bird to give a closing statement.
Thank you very much. We've certainly enjoyed getting a chance to work with the National Archives, and thank you very much for setting up this opportunity. I hope the information we conveyed was useful. If there are any questions at all, anyone participating in this can feel free to contact us. I think you have our contact information. If not, please share it, so that we'd be happy to talk or answer additional questions going forward. But it's been a very, very interesting evening for us, morning for, I hope interesting morning for you. And thank you very much for your hospitality. We're delighted to have been able to participate in this.
Thank you, Mr. Bird. Mr. Betty, could you please give us some recommendation as the closing statement from you?
Well, I'm getting the opportunity to speak after our president once again. I can only echo his sentiments. I personally was very honored to be invited to speak. I was very glad to assemble this presentation and have an opportunity to assemble information on this very, very important topic of paper preservation that is important for both of our countries. And it was also an opportunity to share some of the things that Jim and I and everyone at Preservation Technologies have been able to work very hard on, and that we're proud of what we've accomplished.
Thank you very much, Mr. Bird and Mr. Betty, for the excellent presentation and closing statement. My best wishes are always both of you. Thank you very much.
Thank you very much.
Kita bisa simpulkan bahwa perlunya pendekatan inovatif dalam proses deasidifikasi, termasuk penggabungan secara sistematis terhadap struktur makromolekul dan interaksi fase ke dalam studi penuaan arsip kertas, dan teknik formulasi sampel yang mengisolasi mekanisme dan meningkatkan dengan lebih baik kekuatan ion dan kontrol pH. Proses deasidifikasi tidak dapat memperkuat kertas yang sudah rapuh oleh pengaruh asam. Cara ini hanya dapat menghilangkan asam yang sudah ada dan melindungi kertas dari kontaminasi asam dari berbagai sumber. Proses deasidifikasi merupakan upaya pemeliharaan, perawatan, pengawetan, perbaikan agar arsip statis berdaya guna secara maksimal atau lebih luasnya melestarikan arsip selama mungkin untuk kepentingan generasi yang akan datang. Dalam melakukan proses deasidifikasi yang baik, perlunya kolaborasi yang baik antara para konservator, diantaranya sejarawan, arsiparis, pelaku industri atau penyiap bahan, dan para akademisi yang bekerja di laboratorium arsip dengan selalu melakukan diskusi atau dialog yang terbuka dalam melihat dampak dari perawatan dan perawatan proses deasidifikasi, meningkatkan bahan dan peralatan serta hal teknis bagi para konservator, dan juga meningkatkan jumlah penelitian yang terukur dan jangka panjang ini mengenai perkembangan proses deasidifikasi sesuai perkembangan zaman. Selalu melakukan interpretasi. Komitmen jangka panjang dalam melakukan penyebaran pengetahuan harus menjadi kegiatan inti dari preservasi sebagai jembatan komunikasi antar disiplin ilmu. Karena dengan adanya integrasi dari beberapa teknologi baru dengan pengetahuan, keterampilan, dan keahlian dapat menciptakan inovasi serta kesempatan bagi para konservator atau arsiparis dalam meningkatkan kegiatan preservasi menjadi lebih terukur, ke arah yang lebih baik, serta berkelanjutan. mengutip penjelasan dari Mr. Bird sebelumnya, dari Rin T. Giller sebelumnya, bahwa preservation is a question of management, not of repairing. Yang artinya bahwa pada hakikatnya preservasi adalah bukan proses memperbaiki, namun merupakan bagian tak terpisahkan dari upaya manajemen penyelamatan bagi memori kolektif bangsa. Terima kasih kami ucapkan kepada para narasumber kita untuk hari ini yang telah berbagi pengetahuan dan pengalamannya, dan kami juga ucapkan terima kasih kepada Bapak dan Ibu sekalian yang telah berpartisipasi dalam kegiatan ini. Semoga kita semua dapat bertemu lagi di kegiatan berikutnya. Kurang dan lebih kami mengucapkan terima kasih. Selamat siang. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Salam arsip, salam sehat selalu. Acara saya kembalikan ke MC. Silahkan Ibu Berli.
Baik, terima kasih Bapak Ahmad Dedi Fauzi yang telah memandu jalannya diskusi pada hari ini. Dengan demikian, selesai sudah acara kita pada hari ini. Atas nama Panitia Penyelenggara, kami ucapkan terima kasih banyak atas partisipasi dari Bapak dan Ibu hadirin, serta kami mohon maaf apabila terdapat perkataan maupun perbuatan yang kurang berkenan. Semoga informasi yang telah kita terima pada hari ini dapat bermanfaat bagi kita semua, dan sampai bertemu di lain kesempatan. Serta kami informasikan kepada penanya terbaik pada webinar seri 1 hari ini nantinya akan dihubungi oleh pihak panitia. Terima kasih, selamat siang. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Betty and Mr. Bird.